Good morning, children. Welcome back to the science class. In the previous class, you have learnt about the calculation of speed. Today, you are going to learn about the calculation of speed with the help of distance time graph. Let us revise the topic. Define speed and express the relationship between distance and time as an equation. Speed is the distance moved by a body in a unit of time. Speed is equal to distance travelled by time taken. If a body moves a distance d in time t, speed s is equal to d by t. Yes, what is the function of a speedometer? Speedometer shows the speed of the vehicle in kilometer per hour at any point in time. Then, what is the function of odometer? The odometer shows the distance travelled in kilometers. Yes, speedometer shows the speed of the vehicle, but the odometer shows the distance travelled in kilometers. Now, let us learn how to draw distance time graph for uniform motion and non-uniform motion. First, you need to know what is the uniform motion. When a body travels in a straight line and covers equal distances in equal intervals of time. Equal distances in equal intervals of time. It is said to be in uniform motion. The example of a uniform motion. Consider a scooter traveling on a straight road. Its odometer reading is noted every 5 minutes. This is represented in tabular form. All must look at this table. Time 10 a.m. to 10:30 a.m. Odometer reading 5030 kilometers to 5048 kilometers. Distance travelled in 5 minutes intervals 3 kilometers. At 10 a.m. the scooter is at the starting point, and so time and distance travelled are both 0. At 10:05 a.m. the scooter has travelled 3 kilometers in 5 minutes. For another 5 minutes, it has travelled another 3 kilometers. It can be seen that the scooter travels 3 kilometers every 5 minutes. Since the distance travelled by the scooter every 5 minutes is the same. It is in uniform motion. Its speed remains constant throughout the journey. Let us calculate the speed of the scooter with the help of distance and time graph. Generally, we use the graph paper to draw distance time graph. You know how to find the distance, speed or time from a formula. Do you know that you can also do it with graphs? It's interesting and you get to see the values too. You know the basics of the graph, don't you? Take a sheet of graph and draw the x-axis and the y-axis perpendicular. Thus, an x-axis that is horizontal and the y-axis that is vertical. The point where the two axes meet is called the origin. The place where they intersect is the origin. We mark that as 0. Time is represented on the x-axis and distance on the y-axis. A suitable scale has to be decided on before working on the graph. In this case, let us take 2 centimeters is equal to 5 minutes on the x-axis and 2 centimeters is equal to 3 kilometers on the y-axis. First, look up the value of x, that is 5 minutes. Mark the point that is directly above the point on the x-axis. Then mark the value of y, that is 3 kilometers, and directly to the right of the point on the y-axis. Then mark the rest of the points and draw a line that passes through all the points and the origin. Now you have plotted a distance time graph based on the values in table. Does a single straight line pass through all of the points? If yes, then it shows that the motion is uniform. What can we do with this distance time graph? Let's see. It has already given you information about whether the motion is uniform or non-uniform. What will the distance covered be at 30 minutes? Here, yes, the distance is 18 kilometers. Can you calculate the speed? Yes. The formula of the speed is equal to distance travelled by time taken. In this case, the total distance travelled is 18 kilometers. The time taken is 30 minutes. To convert a fraction into an equivalent fraction, we have to multiply the numerator and the denominator by a same number. Hope you have learnt about this. Here, in order to convert 30 minutes into an hour, we have to multiply 30 by 2. So, we have multiplied the numerator also by 2 to get an equivalent fraction. So, the answer is 36 kilometers. 36 kilometers per hour. What type of motion is shown by a scooter moving on a busy road? It will definitely have a non-uniform motion, as the speed of scooter would not be constant and keep on changing on a busy road. The driver has to slow down and speed up from time to time. The distance covered by the scooter every 5 minutes is shown in this table. 10 a.m. to 10:30 a.m. This is the odometer reading 5048 kilometers to 5057 kilometers. Distance travelled in 5 minutes intervals. Here 1 kilometer, 2 kilometers, then 3 kilometers. It can be seen that the scooter travels different distances every 5 minutes. Since the distance travelled by the scooter every 5 minutes is not the same. It is in non-uniform motion. Its speed is not constant during the journey. Plot the graph for the values in table. What kind of graph do you obtain? Here, the graph for non-uniform motion is not a straight line. It is steep when the speed is greater and less steep when the speed is less. We also observe that when the scooter is not moving, the graph corresponding to the period is parallel to the x-axis. When object travels in non-uniform motion, its average speed for the journey can be calculated using the formula. Average speed is equal to total distance travelled by total time taken. In this case, the total distance travelled is 9 km. The total time taken is 30 minutes. Average speed is equal to 9 km by 30 minutes. Already we have learnt about how to convert 30 minutes into an hour. So the answer is 18 kilometers per hour. Let us revise the topic. Differentiate between uniform and non-uniform motion. Uniform motion. When a body travels in a straight line and covers equal distances in equal intervals of time, it is said to be in uniform motion. Non-uniform motion. When a moving body does not cover equal distances in equal intervals of time, it is said to be in non-uniform motion. The distance-time graph for uniform motion is a straight line passing through the origin. In non-uniform motion, the speed of an object is not constant. Thank you.